Hello and welcome to this PV Tech Tech Talk series webinar, co-hosted this time with PV Evolution Labs. My name's Liam Stoker, I'm the Editor-in-Chief at PV Tech, and I will be moderating today's proceedings. The title of this Tech Talk series webinar is the Top Performing PV Modules, the 2021 PVEL Module Reliability Scorecard. Our presenters today are Tristan Erion-Lorico, who's Head of PV Module Business at PVEL, Tara Doyle, who is Chief Commercial Officer at PVEL. However, kicking us off shortly is Armando Solis, who is Director of Engineering at Lightsource BP. Armando will start us today with a presentation on why testing matters, exploring the impact it has on due diligence processes for Lightsource BP, before Tara and Tristan give us a deep dive into the key findings of this year's PV Module Reliability Scorecard. We will also be hosting a lightning round of quick-fire questions and answers based on the findings of this year's module scorecard. However, if you haven't sent us any questions at all, we will be taking them throughout. Please feel free to use the question session that you can find on your screen. That is the best way to send us questions for today's webinar. And it's also incredibly helpful to us if you can perhaps direct your questions to the person that you feel would best be positioned to answer them. It really does help us kind of allocate those questions. So if you can, that would be absolutely fantastic. And to head off one of the most popular questions that we receive for these webinars, yes, the presentation will be available after time. It will be available on demand on PV Tech. So feel free to kind of sit back, relax, and rest assured that you will be able to view the presentation ahead of time. But without further ado, let me introduce Armando Solis from Lightsource BP. Armando, over to you.
Liam, thanks so much. Good morning, good afternoon, and good evening to all of you. Thank you so much for joining. My name's Armando Solis. I'm the Director of Engineering for Lightsource BP, based here in the US. Primarily, my focus is on our US markets, though obviously being a global present company, we are working on projects all over the globe. Part of what I want to talk to you all today is the experience that I've had as in the solar industry, working with modules, and how I've become very in tune with the PQP and PVEL's product. Part of what the value that it adds to us at Lightsource and Lightsource BP is really with regards to the results and the confidence that it brings to our module procurement strategy as an owner, developer, and operator of large utility scale projects. Modules are obviously a very important component to that, and their longevity is also quite important to us, and ensuring that we can actually have a project standing out in the ground for X number of years, 20 so plus, is quite important. So I'm going to talk to you about a couple points that I identified as key and critical to the value, not necessarily technical, but definitely in terms of how we make our project successful in our US market as well as other markets. The first that I want to talk to you all today about is bankability. Now, I don't mean bankability in the sense of a module manufacturer's balance sheet or anything like that. I mean more so in the sense of supporting projects through financeability. As many of you are very well aware, a lot of projects in the US happen to secure tax equity financing or other construction debt types of financing structures. In order for those to be successful, we need to ensure that we're procuring modules that are of high quality and that can be substantiated for a long-term financing structure. In order to do so, we need to present third-party validation and testing, which the PQP helps support tremendously. Obviously, as a financier or us as an owner are going to be involved and included on a project for 20 or so plus years or even longer, we need to ensure that our asset is going to have a key and quality product for that time, and that we can obviously project those generation numbers accordingly. The next item that I want to talk about is reliability and quality. Obviously, part of the title of this presentation is with regards to reliability, and that is directly related to our project success, our financial projections, our energy projections, and even getting into our offtake agreements and our offtake agreement confidence. one of the key items that we see with the PQP is the reliability in PAN files and IAM profiles. As many of you are aware, we use and rely on PAN files to model our energy projections for our given projects, and having third-party testing and third-party generated files is quite important so that we can confirm and have a validation outside of the module manufacturer to have confidence in those energy numbers for third-party financiers and in our independent engineers. We are very well aware that independent engineers are very involved in the due diligence process. Therefore, it is very important for us to be able to have substantiated third-party results, and the PAN file validation from the PQP is of utmost value. Part of that also relies or results in high quality P90 and P99 values as a secondary result of the PAN file process. As the module market continues to evolve and the solar market continues to evolve, we have seen that financiers look to P90 and P99 financing structures with regards to the energy modeling results versus the traditional P50 numbers that are a result of PV-SYST, which is the common software used in energy modeling in our industry. Lastly, here is degradation. That happens to be quite a significant topic in our solar industry today, and the results and numbers and estimates of degradation continue to flow and are also quite a debatable topic. As technology changes, we move to PERC technology, and then obviously the debate between polysilicon and other thin film technologies out there. Part of what we look for in the PQP and third-party testing is having confidence in what those degradation numbers are communicated from the module manufacturers to ensure that we are getting quality product and that the numbers that we project in our models are accurate. Nextly, I want to talk about risk mitigation in terms of the structural tests that PQP goes through. Obviously, as the module and the solar market evolves here in the US, a lot more projects are being located in high wind and high hail prone areas. It is very imperative for us to understand and know that modules can withstand such high stresses and impacts potentially, because we want to ensure that the module and the solar project are going to withstand any potential events, but also ensure that they can be insured by a third party. We are seeing quite a number of hail claims in the industry, not to say us. So it has become a new thing, and you can actually find an upcoming release from Lightsource BP and PV Tech on hail mitigation and hail mitigation strategies. As I mentioned, insurance is also becoming a critical role and critical part to our success in financing of our projects, both third-party tax equity and construction debt, and ensuring that we have a quality product is and has become a key issue. Lastly, I do want to talk about warranty and agreement confidence. And by agreement confidence, I mean in our module supply. As we have learned over the number of years, while a module may have a specific name or specification, there are various BOMs or bills of materials that go into the makeup of a module. Part of what we look to in the PQP, aside from the results, is understanding the components that are going into the individual module itself and ensuring that our agreements are lined up with those, so that the manufacturer is providing us the same quality product that has been tested, which also helps issue reliance to our independent engineer during the diligence process, and for us to know what we have out there for the next operational years. Those are the key elements to being a long-term owner and an operator, aside from many others that I can speak to. But with that, I do want to pass my time over to Tara and Tristan, who can talk to you more about the results and what the PQP is. Thanks so much for your time.
Thank you, Armando. And as Armando mentioned, my name is Tara, and I have the great pleasure of leading the commercial team at PV Evolution Labs. I am here today with my colleague Tristan Erion-Lorico, who is PVEL's head of PV module business, and we are going to team up to talk through PVEL's 2021 PV module reliability scorecard.
Yeah, that's correct, Tara. And Thanks everyone for joining us today. We're excited to be releasing the 7th edition of the Scorecard today. Obviously, we cannot fit all of the Scorecard's findings into this webinar. So for today's presentation, we've selected some of our favorite aspects. For what we don't have time to cover, we encourage you to read the Scorecard to learn more.
For those of you who do not know us, PV Evolution Labs, or PVEL as we're known in the industry, is the independent lab of the downstream solar and storage market. Our mission, as it was on founding over 10 years ago, is to create the data that matters for solar and storage adoption. We get to work with companies all over the world, including over 400 downstream partners. These are the companies that are the banks, the developers, the asset owners, insurers, folks like Lightsource BP, the PV and storage stakeholder community, and we help support them by de-risking their projects. We have a tremendous amount of experience and data, which we use to support over 30 gigawatts of downstream annual project pipelines. And we are very excited to share the 7th edition of our scorecard with you today. One notable difference is that it is online and interactive this year. We went out on a limb and tried something new and different, and we're very excited about this format. And as with all of PVEL's programs and initiatives, we always love to hear your feedback.
Yeah, well, we encourage you to read the scorecard via the interactive website. Don't worry, all of you traditionalists, there's still a PDF version that you can download and read in that format. Our 2020 scorecard was downloaded more than 8,000 times. And with that many downloads last year, I imagine most people joining us today are familiar with the scorecard. But for those that aren't, here's a quick overview. The scorecard is the culmination of results from our product qualification program, or PQP, what Armando was speaking about earlier. The PQP is PVEL's flagship testing program for PV modules, providing the industry with a holistic data set on module reliability and performance. In the scorecard, we list top performers for many of the PQP tests. The current PQP test plan is shown on screen, and as you can see, it covers extended reliability and performance testing for PV modules. We update our PQP regularly so that the data it generates meets buyer concerns and is appropriate for today's products. Updates are conducted with feedback and input from buyers, manufacturers, research institutions, PVEL's work on standards committees, and obviously our own research and our own test findings. Later in the presentation, we'll share with you a preview for the next edition of the PQP.
And although the scorecard is a useful resource when evaluating suppliers, module buyers also need to review the source data, those PQP test reports, to learn more about top performing modules and more specifically about bills of materials. And PVEL's PQPs, we have them for modules, inverters, and energy storage systems, all work the same way. Basically, manufacturers sign up for testing. Throughout that testing, PVEL provides reliability and performance reports based on resulting data. From there, manufacturers allow us to share these reports with our downstream partners, which we provide complimentary through our on-demand web portal. Our PQP reports provide information that PV module buyers need for technical due diligence, including bills of materials used for the exact modules tested in PQP, and then, as I mentioned, reliability test results, as well as PAN files and IAM profiles.
Yeah, exactly, Tara. The scorecard provides an overview, but for the full information that buyers need, you have to consult the detailed PQP test reports. It's important to understand that a manufacturer could produce as many as 20 or more different BOM combinations for a single product code. And at PVEL, we may have just tested a few of those BOMs. As such, we don't consider the scorecard as a shopping list. We congratulate the manufacturers and their top performing model types, but buyers should go beyond the model type shown in the scorecard and use the full PQP reports to understand the complete test results and the specific BOM that achieved them. That BOM or BOMs can then be specified in module supply agreements so that you're not just ordering a product type and leaving it up to the manufacturer to decide which materials to use. And here's a great example of why specifying BOMs matters so much. A study of PV modules installed in Europe's oldest grid-connected solar power plant shows that material selection can dramatically affect longer-term performance. This site operated for 35 years, and over time, clear differences in module performance and appearance became evident, as can be seen by the images on the left side of the screen. At least 3 different bombs were used at the site, each with a different encapsulant formulation. One encapsulant led to a phenomenal less than 5% average degradation after 35 years, while another led to greater than 25% degradation within that same time period due to the discoloration you can see. In the multi-hundred megawatt sites being built today, this difference in performance between the 2 bombs would have huge financial implications.
But you shouldn't expect these less than 5% degradation rates to hold true in newer modules. Those ARCO modules in Switzerland cost roughly $10 a watt 35 years ago, which by today's pricing is pretty outstanding. And like I said, it's not the case today with products. We've seen prices go lower than 20 cents a watt. The chart on the right shows results from a field survey conducted in India. The survey was conducted on 36 sites ranging from 1 year to 20 plus years old. In this study, younger sites had higher levels of annual degradation ranging from 0 to over 3% compared to the older sites. Now, this may be a function of lower quality materials or lack of quality controls on manufacturing lines. Turning to a summary of our scorecard results, we're seeing pretty similar degradation ranges as were observed in the India site study. Some modules are performing extremely well and others have not.
Yeah, there are certainly some highlights and lowlights presented in this year's scorecard. On the positive side of things, we're pleased to report that this year we have the highest number of manufacturers listed as top performers than in any year in the history of the scorecard. We see continued improvement in thermal cycling and pan performance. And notably, we've seen very strong results from some higher wattage and higher efficiency modules. This is great news considering the power increases we've all seen throughout the industry in the last couple of years. In the not so positive category, the number of manufacturers experiencing a junction box related failure has increased to 1/3, up from 1/5 in last year's scorecard. Many of these junction box failures occurred before testing began, straight out of the box, which is quite concerning. And on the topic of failures, we're also reporting that 26% of all tested bombs suffered at least one failure. We've also seen some surprisingly poor results from a few bombs where, frankly, both PVEL and the manufacturer were alarmed by just how bad the results were. From the general findings I just shared, let's drill down into the results of one of the tests included in the scorecard, thermal cycling. We do this test because it reveals one of the most common field failure modes, solder joint degradation and failure. We're happy to report that the majority of bombs tested this year were top performers for thermal cycling. This can be seen by how many of the green bars in the graph on screen are above the 2% degradation top performer threshold. Compared to our historical results, the median and average degradation following thermal cycling has improved in 2021 versus previous years. And it's worth noting that this test is to 600 thermal cycles as opposed to the 61215 test, which is only to 200 thermal cycles. We're also seeing these strong results across a range of module technologies, monofacial, bifacial, different cell sizes, different interconnection techniques. All of these can have top performing results. But unfortunately, not every product was a top performer.
Exactly, Tristan. While a range of module technologies did well, multi-busbar products performed worse than standard 4, 5, and 6 busbar products on average. There's been an industry trend to more busbars because they do offer some advantages. If, for example, higher output power and power loss due to microcracks. But improper soldering of multi-busbar modules can lead to very poor TC results, as shown in the EL images on the left, where we measured over 10% power loss. Multi-busbar requires a higher level of soldering precision, which some manufacturers have not tuned their process to achieve quite yet. So improper soldering causes problems in the field, and we've definitely known this for a long time. And as the different layers of the PV module expand and contract in the field, solder bonds and cell interconnections are stressed, and TC600 reveals if the module can withstand this stress. The two images on the right show an example from the field of failures that can be screened out by TC600 testing. These are from a 10-year-old, nearly 1 megawatt site in Italy, showing hotspots in the space between the cells due to a lack of strain relief, which is an issue associated with poor quality construction or it could have been poor raw material selection to begin with. PQP testing would definitely have identified this problem.
On the topic of multi-busbar results, and contrary to what we just said about thermal cycling, let's look at another PQP test, the mechanical stress sequence, or MSS. This test subjects modules to mechanical loading followed by environmental chamber exposure, going beyond the IEC 61215 standard test to quantify the power losses caused by cell cracking. And the results from this test show that multi-busbar on average performs better than traditional 4, 5, or 6 busbar designs. Having additional busbars means there is a reduced cell area that can be isolated due to microcracks. You can see this in the EL images on screen. Both modules have a similar amount of cell cracks, but the 5 busbar module on the left has far more inactive areas than the 12 busbar module on the right. We've also seen strong results from glass modules, back contact, and thin film modules going through mechanical stress sequence. It's also worth mentioning that there are traditional busbar designs that perform well in mechanical stress sequence, which speaks to the nuance in our test results and not being able to make definitive generalizations about a single technology always being better or always being worse than others.
So if you're a buyer in the audience, you might be wondering, what does this mean for me? How do I make a purchasing decision when a product performs better in one test over another? And which test is more important? The answer to that has to do partly with specific site conditions. Those are a major factor in choosing the right product. So for example, with heavy snow or wind loading, MSS results might be more important to strongly consider over some of the other test categories. PVEL can support you with these evaluations, and we are really excited to have this as a new top performer category this year, spotlighting modules with lower susceptibility to power loss from microcracks. The other new top performer category this year is light-induced degradation plus light and elevated temperature-induced degradation. At the risk of acronym overload, we'll shorten these to LID and LETID in our discussion here today. As with the mechanical stress sequence, this test is highly relevant to buyers today. When I started in the industry many years ago, LID was a well-known phenomenon, and modeling its effects was a fairly well understood process. With the introduction of advanced cell technologies like PERC, methods like gallium doping, and the emergence of LETID, things have become much more complicated. When we surveyed 6 different global independent engineering firms, we received a range of responses for how they are modeling LID and LETID, which you can see here on the left. There's confusion around how to use LID and LETID values in models, and how this handled has a major impact on project financials.
Yeah, here's an example to explore that major impact. So if a project has a 5% profit margin, an additional 1% of LID plus LETID losses represents 20% of the project's profits. And we're seeing that a 1% range is actually quite common across different independent engineers. Further to that, some IEs don't model LETID in moderate climates, and some are modeling LETID recovery while others aren't. There just isn't a standardized way of dealing with this. We did see that most IEs are modeling LID plus LETID, so PVEL combined the average power loss from those 2 tests for this new top performer category. And this test is a great example of the need to use empirical data to overcome uncertainty. Selecting module types and BOMs that are top performers in this test provides confidence that the LID and LETID values will be kept under control. Another of our favorite PQP tests is PAN. Like LID and LETID, it provides empirical data for modeling that can have significant financial implications. PAN files are the inputs for PVSys, which, as Armando said, that's the industry standard PV modeling software. They model how the modules perform in different temperature and irradiance conditions. I like to think of them as a digital data sheet. For PVEL's PAN files, we measure module output across a matrix of 22 different temperatures and irradiances. We then take this data and use it to generate a PAN file that has a modeled performance with strong agreement with the measured performance. The scorecard shows the 2021 top performers for PAN performance, and it's likely no surprise that these rankings are dominated by bifacial modules due to their higher energy generation.
While this year's top performer rankings show the impact of bifacial designs, a review of our historical data points to other trends that drive increased module performance. Looking at the graph on the left, we can see that temperature coefficients have improved year over year. This means that modules are not as affected by high temperatures. Looking at the irradiance dependence of different module types on the graph on the right, you can see that there is a low light performance increase with P-type monocells over P-type multicells. There's a similar increase moving from P-type to N-type. As the industry is poised for increases in N-type manufacturing capacity, module low light performance is likely to increase even more. And that brings us to everyone's favorite part, our historical scorecard. This slide shows all the manufacturers named in this year's scorecard across our 6 different top performer categories. Any manufacturer with a product listed in any one test appears here. We do encourage you to go to each test results page in our scorecard to see which model types are named in which category.
We'd like to congratulate all of the manufacturers shown here, from our 7-time top performers, Jinko and Trina, all the way down to our first-time top performers. The PQP is difficult. It's not easy to be a top performer. It takes the right combination of product design expertise, reliable bill of material selection, and strong process and quality controls. We have many examples of products that did not perform well, and therefore every manufacturer listed here should be commended.
Unfortunately, we've only had enough time to talk about our favorite findings today. There are 6 different test sequences represented in the scorecard, shown here in the screen on the left, with top performers named for each. We've covered some of them today, but we go into further detail in the scorecard, including how we conduct each test sequence and why. We also have more industry case studies and even more data from the field than in previous scorecard editions. We have the great pleasure of working with some of the companies and partners you see on the screen here as well. Much of the data from field comes from PVEL's own testing on operating assets. We invite you to check out our scorecard, find your own favorite finding, and tell us what you learned via direct feedback or on social media. We'll use your feedback as we develop our next reports and as we update our PQP.
Yeah, and on the topic of our updated PQP, we're looking forward to releasing the next version of our program later this year. One of the biggest changes will be the addition of a new hail test sequence. To come up with the hail test, our engineering R&D team is leveraging data from our field testing operations, where we've gone to multiple sites to assess damage from hail-affected events. And besides hail, another hot topic in the industry is large format modules. PVEL is pleased to be engaged with a number of manufacturers to test these modules in our PQP. Some of those modules and the manufacturers are listed here. Signing up as a PVEL downstream partner will get you access to these test reports as they are completed in the coming weeks and months.
And as module sizes grow and as the industry grows, so does PVEL. We've recently teamed up with the Kiwa Group, a global testing, inspection, and certification organization with labs all around the world, and we are poised to grow with our new partner. We have a lot of plans in store for our companies in the months and years ahead, so please stay tuned and keep in touch. To sign up and start working with us and to join our network, visit us online or contact Tristan or myself.
And to access the 2021 scorecard, please head over to modulescorecard.pvel.com. It's up there and live now.
We want to thank you for your attention thus far, but don't go away. Next up, we have some more exciting program. And with that, let's keep the conversation going with our lightning round. Liam, I will turn it back over to you.
Yes, thank you very much, Tara, and indeed Tristan and Armando for their excellent presentations there. Really some fascinating insights, not just the results with the scorecard testing, which I'm sure we could go over for hours, but indeed how they're being interpreted and applied as well. Now onto our lightning round, as Tara suggested there. How this is going to work, I have 5 questions each for Tristan and Tara. And they'll aim to answer these in exactly, well, no more than 60 seconds is certainly the aim. So I am very much placing them in the hot seat here. Tristan, you're up first. The first question I have for you here as part of the lightning round is, and I'm going to ask you to stick to a top 3 if you can. What are the most important material components to specify in a PV module?
Ooh, starting off with a tough one. Our PQP witness reports detail over 100 different bill of material specs, and all of them, frankly, can have an impact on module reliability. For example, the manufacturer and type of encapsulant that was used is certainly important, but our data shows that the encapsulant thickness is also a critical specification. All that said, I think the 3 components with the biggest impact to module quality are the cell, and the cell. But beyond that, I'd say the encapsulant and backsheet are likely the next most important. But it pains me to not say the frame design when it comes to mechanical durability, the diodes in the junction box that could be taken for granted but affect module quality, the connectors, the glass anti-reflective coating, the cell metallization, et cetera, et cetera, et cetera.
And next up, I'm going to, for these next few questions, I'm going to ask you strictly to stick to one. Which is better, glass or glass backsheet?
Oh man, this is like asking me to name my favorite child, which most of the time is my youngest, by the way, but the other 2 can also be pretty great. The scorecard lists many top performing glass, and glass backsheet modules, so I think either of them can perform quite well. We've also seen examples of not so great versions of both, so I think either of them can perform quite poorly. Rather than pick one or the other that's always better, give me the PQP reports for the specific BOM you're considering. Let me know where the site is, provide me with the site design specs, and then I'll try to help you choose which is best for you and your specific needs.
And again, if I could ask you to just pick one of these, are you in the boron doped camp or the gallium doped camp?
This is almost like a question of the devil you know versus the devil you don't. So gallium's been around for quite some time, but not on the gigawatt scale until the last couple of years. And in our testing, we see gallium doped modules that perform quite well. And I think the boost in production of having no LID is quite significant. And we've certainly seen cases of 0 LID in our testing of gallium doped modules. But my reservation about choosing it is that there could be unknown issues that have yet to emerge. So like LETID wasn't discovered until PERC modules started to significantly degrade in the field. Are we going to find a similar situation with gallium in the coming years? I certainly hope not, and I think the industry certainly hope not. But acknowledging that risk, I'm going to pick gallium, but starting in 2025.
Excellent. And this next question I have is very much subject of debate and something that we've covered quite extensively on PV Tech, certainly in recent months. True or false, are N-type modules the modules of the future?
Yeah. Funny, I recently heard someone state that N-type modules are the module of the future and always will be, meaning they will never be the module of the present. That said, from recent articles and press releases, it sounds like the main crystalline players are finally taking N-type seriously. We've got more N-type listed in the scorecard as top performers than ever before, and that includes PERT, it includes IBC from SunPower as well as non-SunPower IBC. It includes TopCon and heterojunction. And if just one of the top 10 largest module manufacturers hits multi-gigawatt production capacities of exported N-type modules, then I foresee that all of the others will quickly follow suit. And where those big players go, so does the rest of the industry.
Excellent. And lastly, I'm going to really test the measure of your diplomacy here, Tristan. Which wafer size will dominate the market over the next 3 years? Is it 182 or 210?
These questions are brutal. I don't know why I signed up for this. So I think if 210 can prove itself through significant market adoption in the next 1 or 2 years, then I think we'll see a transition to it beyond that. I just can't see the manufacturers that are firmly in the 182 camp lose market share because they don't have a 650 watt module like the 210 millimeter competitors do. That said, when I was a kid, my family had a Betamax player, while all of my friends had VHS, and my movie selection was abysmal. More recently, I've also kept holding my Nokia stocks, which have never bounced back like I was hoping they would. So clearly, you're better off not relying on me to predict the future. Although one prediction that I'm confident in is as these module sizes increase, replacement modules for what is being installed now and in the last few years will become less and less available. That means selecting a reliable module that doesn't require future replacement is more important today than ever before.
Okay, brilliant. Thank you very much, Tristan. Tara, it's very much time for you to pick up the mantle. Very similar. I have a list of questions here for 60 seconds, if you can. But firstly, if you could give us a percentage, how confident are you that today's modules can stand up to extreme weather?
All right, it's my turn. I'm going to go ahead and split the middle here and say 50%. And I say that because today's modules are unproven for long-term field performance, and even the most rigorous tests could not predict how a module will behave through a handful of tornadoes. Modules today, as we know, will be exposed to many weather events over their lifetime. And we all know that weather all around the world is becoming more extreme while PV module costs are falling overall. We know these costs need to get squeezed out of somewhere, and often this happens with raw materials and quality controls. As well as, and Tristan mentioned this, modules for utility applications are getting larger, which means more surface area on a tracker configuration with perhaps mounting design for smaller modules. So technical due diligence will become more and more critical for buyers to require of modules today, as well as in the future.
Excellent. And now I have the first of 3 true or false statements for you to contend with. So true or false, investor requirements for due diligence are becoming more rigorous?
I would say true. And if you're an investor in the audience today, they should be. When I started in the solar industry in the early 2000s, solar was more on the spectrum of the socially responsible or environmentally friendly thing to do, and a lot less of a competitive financial investment. If you fast forward to today, around the world, some of the largest financial institutions are investing in solar. Today's project stakeholders have very little OPEX reserves to deal with underperforming or failed products without completely decimating the already thin margins. We've seen investors adopt more rigorous requirements as well for new projects after going through the pain and heartache of dealing with failures in their current assets.
And this question, again, true or false, but perhaps asked specifically for the asset owners in today's audience. True or false, today's modules will last for 40 years?
You know, maybe a controversial response, but I'm going to have to go with the research on this and say false. Although some products may last 40 years, most of the solar assets existing today that have actually been around for 40 years are in various stages of degradation. And we've seen as much as 20% and written about that in the scorecard. That would completely wipe out today's profit margins. We've also been reporting in the scorecard over the past couple of years that junction box failures are increasing. Modules will certainly not last 40 years if manufacturers don't pay attention to the basics as they advance technologies and grow to gigawatt plus scales. So that said, it is possible that some of the more robust designs could last, especially if the bombs do well in PQP testing. But as for 40 years, I'm afraid only the field will tell us.
And lastly, for your true or false statements, and this one hugely pertinent considering the recent news flow and updates of the last few days as well. Buyers should be concerned about short-term raw material supply chain constraints and price increases that they are causing. True or false?
You know, in the short term, I say true. We've seen this, but in the long term, and even maybe the medium term, I would say false. As mentioned previously, I've been in the industry a really long time, and over that time, I've seen all manner of oversupply, undersupply, sideways supply, and shortages of certain raw materials. Certainly many policy changes around the world that disrupt the industry temporarily, not to mention, of course, a global pandemic that rocked the solar industry and just about every other industry for that matter, except maybe online retail. And I personally had a hand in making sure that succeeded. But here we are with over 150 gigawatts to be installed this year. Now, I do not mean to downplay at all the human and labor rights issues that we are all keenly aware of right now that are in part causing supply chain concerns and disruptions. But I do wish to convey that solar is a very resilient industry, and history tells us that we will overcome challenges of all kinds that may threaten its growth.
And lastly, but by no means least, if you could pick one, Tara, would you either specify a bill of materials or negotiate favorable warranty terms in a supply agreement?
Thank you, Liam, for this nice softball. Bomb all the way. We've seen time and again companies get trapped in a loophole of warranty, or even with the most ironclad warranty, come to find out that there's an exclusion. We also know from experience with our downstream partners around the world and their operating assets that a warranty is only as good as the stakeholders' ability to claim. And that process can be costly, time-intensive, and still may not recuperate losses. We've seen this personally with our field testing for warranty claims. So choosing products and BOMs that have done well in rigorous testing can save the developer or asset owner the headaches of a product warranty claim to begin with.
Excellent. Well, I'm sure Tristan and Tara will breathe something of a sigh of relief now that the lightning round is over and we can move on to the audience Q&A. Just before I start that, however, you can see the pop-up on your screen now, which should direct you straight to the scorecard itself. So if you click the access button there, you should be able to be brought straight to it. Now, for the audience Q&A, we have roughly 20 minutes or so, but we're also not averse to going over if the questions keep coming. So we do have some time. A quick reminder that you can send questions to us using the chat function that you can see on your screen as well. We've been poring over the questions submitted so far, so there's no time like the present. I will kick off with some of those. Perhaps Tara, you could start. We've had a few questions around some manufacturers which are missing from that slide that you showed a couple of minutes ago. Is there any kind of reason for that, or any kind of contribution at all?
Yeah, so we've been publishing scorecards for a lot of years, seven editions starting in 2014. And there are a number of reasons why a specific manufacturer you're seeking does not appear as a top performer in the list. I'll go over very briefly 4 reasons here. One is that they didn't sign up. So we can't report top performer results if they didn't sign up for testing to begin with. The second is, as Tristan mentioned in the presentation, the PQP is difficult and not all manufacturers have top performing results. So that could be another reason. A third one is that they signed up for testing, but results were not ready yet. We see that with the large format modules. A number of those manufacturers, or all of them, have signed up for testing, but some of them do not have results ready. When we publish the scorecard, we have to stop at a moment in time, although we have PQP test programs running all the time. So some results just may not be ready in time. And then finally, we have seen this a few times over the years, but sometimes a manufacturer signs up and they do really well in testing, whether in a particular category or overall, and they simply decide not to be named as a top performer. Manufacturers always have a choice to be named as a top performer or not if their results are top performer worthy, and some just simply choose not to be named. So those are the main reasons, but if you contact me, if you contact PVEL, we can discuss specific manufacturers and which of those 4 cases apply to those manufacturers.
Perfect. Okay. I'm going to group together 2 questions here. the 2% degradation rate that you set for top performers, is there any kind of insight into why that threshold has been set? And have you considered perhaps tightening that if more and more manufacturers kind of gain that top performer status?
Yeah, I'll take that one. So the 2% was set, I believe, in 2018, and we thought it was a good delineation or a good bar to be set. It is a little bit arbitrary. We wouldn't say that 2.5% or even 3% degradation is bad, but it's also looking at the holistic results across all of the bombs we test and coming up with a bar that is well established, and manufacturers know when they get their test reports that if it's less than 2%, they're likely to be in the scorecard. But I wouldn't say again that the difference between 1.5% and 2.5% is the difference between an outstanding module and a terrible one. And about tightening that bar, that's something that we do consider each year when we review our results, but we're seeing that, it's kind of a nice threshold that applies, where we do see better performers coming out. And as I mentioned, in thermal cycling, the median and average has improved this year from historical years, but there still are enough bills of material that perform with results of degradation higher than 2% that raising that bar we don't think is necessary to this point, but it's certainly something we consider every year when we go to write the scorecard.
Excellent, thank you, Tristan. I have a question here that I'm going to ask. Well, I'm going to direct at perhaps you, Tristan, firstly, but I'm also quite keen to get some of Armando's insight into this, given he's very much on the developer side. Do you think that the afterlife or recycling capabilities of a module could be or should be considered a factor when evaluating the performance of the module?
Yeah, we don't necessarily look at that in terms of our testing and the recyclability, although I think everyone in the industry likely wants to do the right thing, and we don't want modules to end up in landfills. We're doing this to make a cleaner world, or at least I am. And so the recyclability is important, but it's not something specific that the PQP looks into. Armando, do you have anything to add to that?
Yeah, sure. So, I mean, as an owner developer and doing a lot of construction, recycling is a key and important thing to us. Especially as you mentioned, we want to make sure that our impact to the environment is as positive as possible. One of the things that we're seeing as a trend is the increase of module prices, and we're all aware in the market that supply of raw materials is beginning to become constrained. Part of my outlook is actually looking into what the future in 10 or even maybe 5 years, where those raw materials may become more and more scarce, and I feel that recycling is going to become very important if there is any sort of way of recapturing the ability of repowering a module or a cell for future deployments. We're building bigger and bigger projects. Modules are getting larger and larger with higher power outputs. So it's going to be key and important for us to know if older modules that have been installed and removed for repowering can be recycled in some manner, and what that likelihood is. Also, when we look at financing projects, that becomes an inherent value because that asset has some form of capital when it comes to capital value when it comes to recycling, and if we can ensure or show that those modules can be recycled and have some inherent value, there is some potential upside on our financing numbers.
Excellent. I'm just scrolling through the list of questions, some really, really fascinating questions coming in. Tara, I have a question here on soiling. has PVEL looked into testing the impact of soiling on different modules, or is this something that you could perhaps look into in the future?
Yeah, so over the years, we've done a number of different soiling studies, and mostly just for a single client looking to vet one product or the other, or a coating manufacturer looking to do third-party testing on their product. But PVEL is always innovating and always introducing new test programs and new studies, and we have definitely looked at some possibilities in terms of a comparative energy yield, a larger study on soiling and the impacts to performance. So would love to get in touch with the person who asked about that question, and would love to work with you to scope something out that would suit your needs, and probably suiting your needs would suit the needs of many others. So would love to explore that program with you a little bit further. So please get in touch with me, and would love to keep that conversation going.
And I guess perhaps staying with you then, Tara, I have a question here. Are you kind of, as an organization, concerned that because manufacturers can replicate the PQP testing in-house, that they could perhaps engineer their own materials to pass as this top performer status, but that may not necessarily be replicated in better field reliability?
Yeah, so this is a fantastic question. Manufacturers are free to test whatever they'd like and however they'd like in their factories, and it probably wouldn't surprise me at all if they did pre-PQP testing on products before they would send them to PVEL. Key differences here are that, with certification testing, manufacturers can choose the samples. So, there's always been a concern about the golden samples or cherry pick samples. With PVEL, certainly they can engineer and choose, the best performing materials for the bombs and whatnot. But the key differences are two things. One is PVEL and our auditors are in the factory witnessing over 100 points of the bill of materials and writing those down. And then they wrap the crates in tamper-proof tape, and they send them to PVEL for PQP testing, where we cut the tape, verify that the audit was done and correctly, and look at the bill of materials that were submitted for testing. And so if that bill of materials does well, the really key and important thing is specifying the bill of materials that does well in PQP testing. So even if the manufacturer chooses the best of the best and the PQP, and they do really well in PQP, you as a buyer have the option to specify the bomb that did well. So if they're engineering and they're making the best module to send for PQP testing, that only works in your favor, because then you can specify that and get that really great performing module and that great performing bomb for your project site.
Excellent, thank you very much, Tara. Perhaps I could throw this one over to Tristan then. Materials is something that we've spoken of, particularly around shortages and supply chain constraints. Does fixing a bill of materials make things complicated in terms of the raw material shortages, and what is the extra cost incurred when fixing a specific bomb?
Yeah, I think there's a bit of a misnomer here, because we keep saying, the good performing bomb, specifying the bomb, and we're using it not in a way that represents the fact that manufacturers and a lot of the manufacturers that work with us test multiple bills of material, and those bills of material can, in some cases, a lot of them can have very top performing results. And so, don't think of it as that you're locking in one single bill of material and saying to the manufacturer, you must use this one encapsulant or this one backsheet or this one cell. We've got a lot of traction with manufacturers where they're testing a range of their bills of material, and they've got good results across that range, and then that range can be specified. And I believe that helps address material shortages, so that it gives the manufacturer some leeway into what they're going to use for your modules, and helps address, should there be a shortage, they've got an alternative encapsulant to turn to, or an alternative cell to turn to. And we would certainly encourage the downstream, the module purchasing community to to tell their manufacturers, if they get pushback about, specifying that single BOM, well, how come you're only testing a single BOM combination? You should be testing more to give both the manufacturer and the module purchaser flexibility on what can be purchased. And that would be our recommendation there.
Excellent. I'm going to open this next question up to all three of you. Actually, I'm sure you all have insights, but when it comes to shipping, whether it's pricing, logistics, how things are fitting into actual shipping containers, as the panels become heavier, certainly larger in size, what kind of considerations are having to be taken here in terms of the potential impact on performance if they're either loaded incorrectly or kind of suffering undue stress during the shipping phase?
Yeah, so maybe I'll start with that and then pass it over to Tara or Armando. So we certainly see shipments arrive in all sorts of different conditions. In a lot of cases, manufacturers are packing the samples they ship to us very securely. And in other cases, we've seen pallets that have completely fallen apart. And, that's obviously a finding for us. We don't do testing on the full pallets. There is an IEC standard that's available to address that. The number is escaping me, but if you have interest in that, please reach out and I'll let you know what it is. And I would encourage module purchasers to ask manufacturers for the test reports to that IEC standard. And that puts, the whole pallet through a drop test and an inclined drop test as well, and different impact tests to look at the durability of the pallets. And I think that's really important, particularly as modules get larger and larger, and pallet designs need to protect them. Armando, oh, sorry, go ahead, Tara.
Well, just a quick anecdote, and then I'll turn it over to Armando. But I've worked at the lab for a lot of years, and I've seen all manner of packaging. And one of the most shocking incidences happened where we received some modules that were glass, frameless, and basically packed with such little regard to the fragility of these modules, especially coming from overseas, that they were basically wrapped in, a single zip tie. So, cutting that zip tie, if you're not extremely experienced with handling modules, and especially frameless glass, the modules basically toppled over. So, I got to believe that when manufacturers are sending modules to the lab to PVEL, they're taking great care to package them so that they don't incur damage prior to arrival, prior to even stress testing them. Although we see a range of behaviors in this regard too. But if they're shipped to us haphazardly, I often wonder how they ship to the project sites and what kind of conditions they arrive in there. So it's a very interesting thing that seems like it should be solvable. Much more, much easier to solve, I would say, than the actual technology and the performance of the product. Shipping something with care should be a no-brainer and a gimme. So yeah, I'll turn it over to Armando. He's got some interesting insights on this, I'm sure.
Yeah, thanks, Tara. So Tristan, just to go back, the IEC is a 62759, and we certainly look at that as part of our qualification for our module supply, and it gets incorporated into our supply agreements. And shipping is very important once we get into construction. Obviously, since we follow the model of modules being an owner-supplied equipment, we want to ensure that the modules are arriving intact, that there isn't any potential damage to the volumes of modules arriving on site, and that offload is in a safe and clean manner when they're coming off of shipping containers or trucks. Going through those measures to ensure that we're not going to have module failures during shipping is important, because that affects how many modules we have to procure. which has a direct capital cost. And then the uncertainty with regards to modules that may have suffered damage that is non-visible at the point of installation during additional testing in the field for acceptance, because if we have to go and rip modules out after some IV curve tracing or thermography testing because they were failed during that shipping, it's not exactly great. Obviously, there's a debate as to whether those modules were damaged in shipping or during the installer's handling of them, but that's a debate that's really never going to end. So shipping and module packaging is very important, and we also look at the materials that are used for shipping, their recyclable ability. That's probably not a word, but I'm going to go with it. And that's quite important to us, as well, as we're looking to reduce the amount of waste on our projects while still ensuring that we're receiving our modules fully intact. The last point I'll make here is actually in experience with working with PVEL on having modules tested outside of PQP for our own benefit, is ensuring that we have the suppliers ship modules as if they were shipping them to our project sites, perhaps pulling them as a random selection of modules that they would have prepared to ship to a project, to ensure that we're not getting anything that is, I guess, in a manner coached up or made better than what you would typically see. Because obviously getting a pallet that is to the extreme care isn't necessarily going to be representative of what we're actually going to get in the field.
Perfect. I think we've got time for just one more question. So I'm going to wrap up quite a few questions into one. There's been a few questions around the kind of the future hail tests and the hail sequencing that you have planned. So perhaps if you could go into a bit more detail around your plans around that, whether you'll be forming static or cyclic loading after the impact, just basically give us a bit more detail on those future hail tests. I think that would be great.
But Liam, if we told everyone now, they wouldn't come to our webinar where we release the hail test in a few months. I can say that right now it's looking like it will be similar to the mechanical stress sequence, where instead of SML or static mechanical loading at the start, we'll do some hail impacts, and then it will go through dynamic mechanical load, thermal cycling, and humidity freeze. We've seen that with our mechanical stress sequence, there's a certain amount of power loss after the initial impact. For that test, that impact is static mechanical load, and then the power loss increases as we go through dynamic mechanical load and through climate chamber testing. And I think one of the big gaps with hail testing right now is that in IEC 61215, that first of all, the hail size is quite small, only 1 inch or 25 millimeters, but there's no post-stress testing after that. So I think all of the modules we've ever tested to that particular test have passed, and you don't learn very much when every module passes. So our hail test is going to use a larger hail size, and then we're going to do some post-hail stress testing to really see how much power loss can happen in the module after that impact. So unfortunately, I think I just gave it all away.
But that said, I'll just add really quickly here before we wrap up that we always love to hear from our downstream partner community. We obviously have a lot of experience from our own testing in the field, from hail incidents, but if there's some direct feedback or insight that you love for us to have as we are continuing to develop and release our test, we would love to hear from you.
Excellent. Well, I think that's as good a position to leave us on today. As ever, today's presentation will be available shortly after. You can stream it on demand via the PV Tech website. You can see on your screen here once again the pop-up to access the module scorecard directly, or alternatively, if you want to have a flick through that later, you can do so at modulescorecard.pvel.com. There's nothing left for me to do but to thank our presenters today, Armando, Tristan, and Tara, and indeed all of you for attending. I hope to see seeing you again for the next PV Tech Tech Talk webinar series at a later date. Thank you very much.
Thank you, Liam. Thanks, everybody.
Thanks, everyone.